Welcome, students, to our third week discussion of Earth and Life Science subject. Our first lesson is all about the Earth's internal heat. Our most essential learning competencies are describe where the Earth's internal heat comes from and describe how magma is formed, magmatism. Our objective is to describe where the Earth's internal heat comes from, identify the sources of Earth's internal heat, describe the parts and function of Earth's interior, describe the process of heat transfer in Earth's mantle. Heat energy plays a vital role in our planet. It is one of the extreme factors in what makes the world livable. Without heat, life on Earth is not possible. One of the examples is the plant. Plant life relies on heat, among other things, to survive as well. But the question is, where did the heat on the Earth came from? There are two sources of heat in our planet. Number one is the primordial heat, and number two is the radiogenic heat. During the early formation of Earth, the internal heat energy that gradually gathered together by means of dispersion in the planet during its few million years of evolution is called primordial heat. Primordial heat is the heat generated during Earth's formation. On the other hand, the thermal energy released as a result of spontaneous nuclear disintegration is called radiogenic heat. Radiogenic heat is the heat generated by long-term radioactive decay. It involves the disintegration of natural radioactive elements inside the Earth like uranium, thorium, and potassium. Uranium is a special kind of element because when it decays, heat is produced. The radiogenic heat is produced by the radioactive decay of isotopes in the mantle and crust, and the primordial heat left over from the formation of the Earth. How does the Earth's internal heat redistributed? It is distributed through the three types of heat transfer on Earth. Number one is the conduction, two convection, and three radiation. What is conduction? Conduction governs the thermal conditions in almost entire solid portion of the Earth, and it plays a vital role in the lithosphere. The process happens in the Earth's surface. Conduction is one of the three main ways that heat energy moves from one place to another. This illustration will show how the conduction happens in the Earth's surface. Heat from the Earth's core and radiation from the sun is transferred from the surface of the Earth by conduction. And this is the inner core. The heat are transferred through conduction. While convection, it involves transfer of heat by the movement of mass, which is more efficient means of heat transport in the Earth compared to pure conduction. It is the transfer of heat due to the bulk movement of molecules within fluids including molten rock. This illustration shows the convection cell. The warm materials rises up to the surface of the Earth and the cool materials sink. That's the process of convection. These cold materials will eventually turn to the land formation. In mantle convection, the heat source is the core. The core of the Earth is very hot. It is nearly as hot as the surface of the sun, about 6,000 degrees Celsius. Convection current is relevant to the movement of tectonic plate because the heat builds up pressure underneath the crust. The tectonic plates, as they become unstable, they push against each other, which is the subduction, and rise upward as one goes under the others. That is the convection process. Again, in convection, the warm materials rises and the cold materials sink in the lithosphere. And last is radiation. It is the least important mode of heat transport in Earth. The process of heat exchange between the sun and the Earth through radiation. It controls the temperatures of the Earth's surface. Now, we're going to proceed on the lesson 2 of the week 3, which is the magmatism. Our objective is to describe the characteristics of magma, identify the substance elements present in magma, and explain the process involved in the formation of magma. Look at the picture. That is the picture of Taal volcano. Do you still remember what happened to Taal volcano last January 12, 2020? Yes, you are right. This volcano is located at the province of Batangas. It spewed ashes, fumes up to 9 miles or 14 kilometers into the air due to the stream-driven or phreatic eruption last January 12, 2020. According to the Philippine Institute of Volcanology and Seismology or PHIVOLCS, for the past 2 decades, over 600 volcanic tremors have been recorded, which was an indication of continuous movement of magma or molten rocks beneath the volcano. The next picture is the Mount Mayon. It is one of the most active volcanoes in the Philippines. It erupted for 8 minutes last January 23, 2018, spewing a 3-mile tall column of debris and volcanic gases. It exploded at least 5 more times for 2 days. According to Philippine Institute of Volcanology and Seismology, or PHIVOLCS, 2 explosion types earthquakes had occurred as well as 18 tremor events, some of which sent forth fountains of lava. One of the lava flows advanced nearly 2 miles from the summit's crater. Maybe you are wondering how the magma gets inside this volcano. When we say magma, it is composed of semi-liquid hot, molten rocks located beneath the earth, specifically in the melted mantle rock and oceanic plate. And what about lava? Lava is the molten rock that has reached the earth's surface through volcanic vents. That is the difference between the magma and lava. Magma is the molten rock stored under the earth's surface, while lava is the molten rock that has reached the earth's surface through volcanic vent. And magmatism is the process under the earth's crust where the formation of movement of magma occurs.